ability to hear stems from a process called auditory transduction. Sound waves, longitudinal pressure waves, are caught by the outer ear, the outer visible portion of the ear, and are directed into the ear canal. Upon arrival, sound passes through the external auditory canal, where it then meets the tympanic membrane, a thin membrane that closes externally the cavity of the middle ear and the functions in the mechanical reception of sound waves in their transmission to the site of sensory reception. Just beyond the tympanic membrane lies the middle ear, a small membrane-lined cavity that is separated from the outer ear by the tympanic membrane and that transmits sound waves from the tympanic membrane to the partition between the middle and inner ears through a chain of 3 tiny bones. The tympanic membrane vibrates in response to the sound, much like this cup of water does when I tap the table, which articulate with the malleus, the outermost bone of the 3 ossicles in the middle ear, the incus, the middle bone of the 3 ossicles, and the stapes, which is the innermost of the 3 ossicles. The ossicles vibrate due to the movement of the tympanic membrane and pass on the information of frequency and amplitude. The stapes moves like a piston and sends vibrations to the bony labyrinth, which is filled with a fluid called perilymph that is found between the membranous and bony labyrinths of the ear. The vestibulocochlear nerve, located in the bony labyrinth, connects the inner ear, the essential of hearing, and equilibrium that is located in the temporal bone, with the brain and transmits impulses concerned with hearing and balance. The flexibility of the oval window, an oval opening between the middle ear and the vestibule having the base of the stapes attached to its membrane, allows the movement of the stapes to displace the perilymph, allowing vibrations to enter the labyrinth. The entrance leading to the oval window is found in the spiral portion of the bony labyrinth called the cochlea, which is a hollow tube in the inner ear of the higher vertebrae that contain the sensory organ of hearing. The vibrations from the stapes are drawn into the spiral system, which are returned to meet the oval window. The cochlear duct, which sits between the scale vestibuli and scale of tympani, is filled with a fluid called endolymph, which is a watery fluid in the membranous labyrinth of the ear. The actual nerve impulses are generated by hair cells, a cell with hair-like processes, in the organ of the corti. The deflection of the hair cells open mechanically-gated ion channels that allow positively charged potassium, a molecule that has a positive or negative charge that gains or loses an electron, or calcium ions to enter the cell. Unlike most electrically active cells, the hair cells themselves don't cause the action potential. The rush of positively charged ions from the endolymph depolarizes, a process of neutralizing polarity, the cell, causing the action potential voltage-gated calcium channels to open, allowing calcium ions to enter the cell and release neurotransmitters, a substance that transmits nerve impulses across the synapse at the basal end of the cell.